All right, let's learn about mechanical energy. So before I start, we're just gonna look at this equation over here. So mechanical energy 1 equals mechanical energy 2. So what this is saying is that the energy at the start is equal to energy at the end, which makes sense because we know energy is conserved. So in this case, the energy at the start has to equal energy at the end. And you're gonna break the energy up into two different parts. So kinetic energy and then potential energy. In this case, potential energy is only going to be potential energy for gravity, which is equal to mass times gravity times height, and then kinetic energy is equal to 1/2 of the mass multiplied by velocity. And keep in mind here that there's a velocity at the start, velocity initial, and then velocity final. So those are two separate things. They're going to be two separate numbers. And then the height at the start is different from height at the end. Anyways, let's get into the problem here. So there's a ball, it's starting at rest 20 meters up in the air, and it's going to go down to point 2, which is right here, where it has a velocity that's unknown, and then its height is equal to 0. So I know it looks like there's still a little bit of a height, but we're going to say height is equal to 0 there. And then over here, we're trying to find the velocity right here, and it's 12 meters up. So yeah, I'm going to set height 2 equal to 0 here. So height 2 is equal to 0 meters, which means this height 1 right here is equal to 20 meters. It's important that you do this because height 1 is 20 meters more than height 2, and then height 3 is 12 meters more. Height 3 is 12 meters more than height 2. And then actually I'll set this to positive. It's positive 20 meters. Okay. Anyway, so let's go into finding velocity 2. So we're going to use the same equation from over here. So me1 equals me2, so me1 equals me2. And then I'm going to skip ahead to writing in the next part. So I'm going to skip ahead. There we go. So I wrote it in the whole equation there. And then some important things that we have to do. So right off the bat, we can see this term right here. So VI squared. If we look up here, we see that V1 is equal to 0, right? So that means we can erase this whole term, because if VI equals 0, then this whole term is going to have to equal 0. So this whole thing right here has to equal 0, right? So we can take that out, and then it's going to be replaced with 0. So it's worth nothing, right? And then this one over here, so the height equals 0 over here. So we can also take out this term because mass times gravity times 0 is just all equal to 0. Okay, and actually I'll just take away this one. There we go. So next thing we have to note here is that in this equation here, we're not given mass at all, right? And even if we were given mass, let's say we set mass to equal 1 kilogram, it wouldn't matter because mass is in both terms here. So we can actually take away mass. So this mass can go away. And see, now the equation looks a lot simpler, right? So what I'm going to do is I'm going to move the 1/2 over to the other side. I'm just going to square root both sides, and then I'll get an answer. So I'm going to skip ahead and do that. Okay, and then another thing to note here. So when I move this 1/2 over to the other side, the reason why I do multiplied by 2 is because multiplied by 2 is equal to dividing by 1/2, right? So those two things are equal to each other. So it's like dividing by 1/2, but it's also like multiplying by 2. So that's why I did that. And then the other final thing, so this is going to be our final answer. So now you might be a little bit confused on why I'm not adding in a direction. And that is because when you're dealing with energy stuff, you don't have to have a direction because it's all scalar. Like energy is scalar. So this 19.8 meters a second, like we know that it's in that direction right there, right? But you're not actually going to write the direction down. So that's going to be our final answer. That's the velocity, or that's the speed. So let's do number 3 now. So number 3, we're trying to find the velocity right there, but it has a height now. So our equation is going to be a little bit more complicated. Let's use point 1 to point 3. So we'll say mechanical energy at 1 is equal to mechanical energy at 3. And then I'm going to skip ahead and fill in all the numbers. Okay, so I filled in all the numbers here. So before I go again, or before I go to the next step, so remember we can take away the initial kinetic energy right here because VI is equal to 0. And then I'm also going to take away all the masses because, again, you can divide by mass on every side and it won't affect your end result. Now, one thing about the mass, so if it asks for like kinetic energy, which is in joules, then you're going to have to use the mass, right? Because then you'll have to multiply like this whole term. Imagine there's mass there to get your energy, this whole term by mass to get energy. But in this case, it doesn't matter because we can just divide mass out of everything and we're just finding VF, so it doesn't matter. But in the case where you were to find energy, you'd have to keep in the mass. So if you're dealing with energy, don't take out the mass. But in this case, it's just final velocity, so we don't have to do that. Okay, so we have 3 terms here. So we have this term, that term, and this term. So I'm going to move this one over to that side. This is going to become GHI subtract GHF. And then I'm going to divide by 1/2, which just becomes, remember, it just becomes 2. It's like equal to multiply by 2. And then VF squared. And I'm also going to factor out the G on both sides here. So G is going to come out in the front here. So it's going to be 2G HI minus HF equals VF. And then I'm going to square root both sides. So then square root up here. Okay. And now I'm going to skip ahead, fill in the numbers with the numbers from up here, and then I'll get our final answer. So I'm going to skip ahead. Okay, so I got our answer here. So again, I just filled in HI equals 20 meters, and then H3 equals 12 meters, and then multiply everything together, square root it, and you should get 12.52 meters a second, which is equal to 12.5 meters a second when you round it. So that's our final answer. Anyways, so that is how you would use mechanical energy to find velocity of these 3 different, or the marble at 3 different places. So remember, you can always take out mass if you're dealing with finding, for example, velocity. And then you should also take away any terms that are equal to 0. So those are the 2 things that you should remember. It should make it a lot easier. If you don't do that, if you don't take out the mass, it's fine. As long as you're given mass, you can still do it that way. But it just makes it a lot easier to keep it in, or to keep it out, I mean. Anyways, that's all. Let me know in the comments what I should make next.